So we're going to look at part 2 of this video on Module 6, Topic D, Bivariate Categorical Data. And now what we're going to do is we're going to start moving from just looking at two-way frequency tables to two-way relative frequency tables. So this is a deliberate switch in tack, and the reason why we're doing a part 2 video for this is that now we're not just looking at the two-way frequency tables like we did before. What we did before is we looked at, well, here's the two-way frequency table that we looked at before. It looks very similar to this. So this data is students that played sport and played musical instruments in a class. And you can see, well, the correlations, who played both, who did not play either, who played one but not the other, and the other but not the one. So you've got all this information. You can, of course, find out the total of students who played musical instruments, the total of students who did not play musical instruments, or you can find out the total of students who played sports and who did not play sports. Right. We looked at that before. We looked at the frequency tables, which gave us that information. Now, what we're looking at is relative frequency tables. So we don't really care much about the quantities of people. At this point, we want to know the percentages of people. And there's, of course, various ways of figuring out the percentages, but it all boils down to the part divided by the whole. All right? So that's really what we're looking at in every single situation. Okay, these questions, though, you'll see them as we go through them. In this case, we're looking at the row totals. In the other case, we'll be looking at the in other cases we'll be looking at the column totals. But specifically, what we're caring about at this point is the students who played musical instruments. We're not really concerned about the students who played sports in this case. Now, when I say part divided by a whole, Khan Academy is very generous to you. It will not accept a percentage. So if you were to actually put in a percentage, let's say like 65%, it doesn't like that. Okay, so don't try that one. However, it will take decimals or it will take fractions. If you do choose to use decimals, make sure you're rounding to the nearest hundredth. I like to use fractions because it means I don't have to pull out my calculator and figure out what the division is if I can't do it quickly in my head. Okay, so I do like to use the fractions. Khan Academy is only worried about that you know how to solve it. The part divided by the whole. That's what a percentage is. The part divided by the whole. And of course, your rows should add up to 1. So looking at this here, we got the students who played musical instruments. We've got 6 who also played sports and 6 who did not play sports. 7 that did not play sports. The total for that is 13. And the students who did not play musical instruments, 8 plus 3 is 11. Okay. Now these are important because we do need to use them to solve this. Well, this is as simple as its corresponding place in the table above. So this one here is going to be 6 over 13. This one here is going to be 7 over 13. This one here is going to be 8 over 11. And this one here is going to be 3 over 11. And the whole point there is it's giving you the percentages. If you do a quick calculation, on this, if you were to say, well, okay, I want to know what percentage of students play musical instruments and play sports. Well, what I'm going to do there is I'm going to say, well, I've got 6 students who play musical instruments and play sports out of a possible 13. And that gives me, this percentage here gives me 0.46 or 46%. Okay. The key thing here is when we look at data, we usually talk in percents. We don't usually talk about the actual figures. But how to figure it out is essential. Is just knowing how to figure it out. And these fractions here will show you how to figure it out rather than just solving it. So let's move on from there. Okay, same situation. The key thing here is look at what we're examining. In this case, we're examining the populations of people who drove sports cars or people who drove SUVs. Okay, so in this case here, our sports cars are going to be, the total people who drove sports cars was 139. The total people who drove SUVs is 125. Okay, so once again, all we're saying is, okay, in the SUVs column, 28 out of 125 had an accident last year of the people who drove SUVs, and 97 out of 125 did not have an accident last year. And in this case here, 35 out of 139 had accidents, and 104 out of 139 did not. Okay, so once again, these are percentages. We're just saying out of, and showing that this fraction will find the percentage for you. Okay. Now, the other type of question that it's give you is going to give you a multiple select question. Note that this is, you do need to choose all answers that apply, so be careful with that. You'll notice the third one here is a none of the above, so you only select that one if you're selecting neither A nor B. But remember that it is possible for both A and B to be valid answers, so we do need to look at that. So we're looking at the behavior of students and the use of candy in that as a positive incentive for that group of students in this elementary school. So what are the conclusions? Let's take a look at it. Okay, so the first one's here. More of the students in the study received candy than did not receive candy. Well, let's take a look at that. Received candy versus did not receive candy. Well, you have here received candy. Well, there was 19 plus 9. That there is 28. And did not receive candy is 8 plus 6. Well, that's only 14. So more students in the study received candy than did not, and that is true. Okay, so more than half of the students in the study who received candy exhibited undesirable behavior. So now we're just looking at the received candy and exhibited undesirable behavior. Okay, and this is claiming that more than half of the students, well, clearly 9 is less than half of that total 28 students. So that is clearly not false. So we're just going to go with the first one. So once again, we're looking back at the rows and columns. This is a patient's family history, depression in a patient's family history, and depression of the patients. And we're looking right here. We're looking at the rows, so we're going to add up the rows. We know that's what we've got to do first of all. So we're going to go with, in this case, we have 35 in the first row, and 28 plus 112 is 140. So 35 plus 140, or 35 and 140 are the totals. So from there, we're just going to plug in our values. So this is going to be 16 out of 35. So 16 of the patients that had depression, 16 out of 35 of them also had depression in their family history, and 19 out of 35 of them did not. Okay, of the patients that did not have depression, so 28 out of the 140 of them had depression in their family history, 112 of them out of the 140 did not. Okay, so that is, I hope, not too difficult. It's just about adding the rows or adding the columns and figuring out, well, how many out of, and understanding that this is a calculation for a percent. Moving on to the next exercise we're going to cover right now. The next exercise is reading the two-way frequency table. So we've already looked at frequency tables and relative frequency tables. Now we're going to talk about reading them. Once again, I'm going to highlight the fact that all of these have this bold question here, and the bold questions change even if you have similar situations. So we're talking about the Facebook use. We've looked at Facebook use before. The data here might actually be the same, or it might be different. In fact, it looks somewhat the same, but the questions all change. So what percent of students in the sample do not use Facebook? What percent of students in the sample do not use Facebook? And note that right now we're being asked for percent. So before we actually did the division, we had the 0 point whatever in decimal form. Now we're being told, well, you do need to multiply that times 100 to get the percent. And we're being told to round to the nearest percent. So we don't want any decimal places here. So what we have here is percent of students in the sample that do not use Facebook. So this is the total people who did not use Facebook as a percent of the sample. Well, the sample is 219. So we're looking at 71 divided by 219. And feel free to use a calculator for things like this. So we've got 71 divided by 219 is going to give us 32.4%, and we're going to plug that in. So 32.4%. The next question here is giving us teams in the NFL and the AFC, or the NFC and the AFC in the National Football League, and we have data here about about their mascots, whether they're animals or non-animals. Okay, so what we're being asked here is what percent of teams in the NFC have an animal mascot. So we're just looking at the teams in the NFC. We don't care about the total. So what percent of the teams in the NFC, that's 16 total, have an animal mascot, which is 8 out of 16. We can see right there. We don't even need the calculator for that. We can see that's 50%. Okay. All right. One more question in here. We have opinions on campus housing in the university. We've got 200 total in the sample right here. There's our 200 total in the sample. And our question is asking us what percent of students in this sample were male. So it's talking about the sample as a whole, so we know that it's out of 200. Okay. How many of them were male? Well, we know that the total males were 90. So that's 90 out of 200. And once again, if you want to plug in 90 out of 200, and that gives you 45%. Okay, so that's enough on those two beginning relative frequency tables right now. We're going to move on to one more and talk about interpreting two-way tables. So in general, interpreting two-way tables is we're talking about frequency tables, two-way frequency tables. We've got various different situations. So we've got a poll here. They were asked if they approved of President Obama's performance in office, and the table shows the results from 2019 to 2014. So how many approved, how many disapproved? You're going to be asked to choose one answer about it. So were students polled on April 27th, 2019. So that's this one here. Were they in this data here? Were adults polled in there more likely to approve of President Obama's performance than adults who were polled here? So were they more likely to approve? Well, we have different sets of data here. It's not clear here whether the data is exactly the same. Well, first of all, we've got a random collection of, they're different. We've got a random collection of 1,500 adults. So both of these should add up to 1,500. So what we have here is we have, in 2014, 650 out of 1,500 approved. In April 27, 945 out of 1,500 approved, making April 27 more likely to approve. That's a higher number, so we could choose yes for that one there. Okay, this one here, Global Wellbeing Index, checking this one out here. So a study across 135 countries in 2013, okay? So about whether they're thriving socially or not thriving socially in the Americas or sub-Saharan Africa. So there are various different regions. You can see this is a relative frequency table. We've got percentages here essentially, okay? So according to the study, are people in sub-Saharan Africa more likely to be thriving socially than people in the Americas? So we're looking at thriving socially. are people in sub-Saharan Africa more likely to be thriving socially than the people in the Americas? Well, the answer to that is quite clearly no. 16% is definitely lower than 43%. Moving on to here, we've got 200 people polled, and we have sleeping with a smartphone out of reach or within reach. And this is an interesting one here. There's a lot of data coming up on this now at this point in time. It's worth looking into it. But the likelihood of doing this and based on age. So we can see here, we're being asked, I mean, there's multiple different things you can infer from it, but we're being asked how many of the adults polled that were 65 and older sleep with their smartphone within reach. Now this is specifically asking you how many. So in order to do that, we must know how many of them were polled. So we know here that of the adults polled, 200 were 65 or older. So we know that the total in this column is 200 people. And we know here that 38% of them are sleep with their smartphone within reach. So in this case, what we're going to do here is we're going to take our total and we're going to multiply it times our percent. So times 0.38. And what that's going to do is it's going to give us that part. Remember, we divided it before. Okay, so if we're trying to get back to the number, we're going to need to multiply it. Okay, so we've got 76 out of 200, and there's our answer right there. I don't know how many they're giving you a couple of possible answers. And notice you've got one here that says not enough information. Be careful about choosing that. Make sure you've actually read everything involved. Notice there was something up here that we needed to have as well. And you can even see here there's more data there that could have been necessary based on the question. So let's move on. Next one here. Once again, observe the total right here. We might need that. We're not entirely sure yet. So we've got a two-way table of row relative frequencies. So there's your row relative frequencies on age on data and risk of obesity. So we're of basketball players. So we're being asked how many basketball players in Denver are age 18 to 24. Well, we have 18 to 24. This is the total here. So we've got a total of basketball players aged 18 to 24. All right. We have 992 total basketball players. Okay. We have 992 total basketball players. Okay. When we look at this, well, we have a row relative frequency table. So if we knew how many were in this age, we could find out how many are at risk of obesity and how many are not. Even if we knew how many were of this age here, we could find out these. And if we were able to find out those, we'd be able to find out the lot. If we were able to find out just one of these, we would be able to find out what we're being asked for here, how many were aged 18 to 24. But in this case, we're kind of struggling to find there's something missing. There's something extra we need, which is not forthcoming to us. So we're going to have to defer on this one and say that there is not enough information on this one. Okay, but notice how we've actually gone through it and we've actually said, well, what do we need to be able to find that out? And we don't know right now. In this question, we have an 8th grade class that took an exam on two-way frequency tables. And after grading the exam, we've got a two-way frequency table to show the data on completing the exam review sheet and passing the exam. So the students who completed the review sheet, passed the exam, did not pass the exam, did not complete the review sheet, passed the exam, did not pass the exam. We're being asked here, were students who did not complete the review sheet, students who did not complete the review sheet, were they more likely to have passed the exam than students who did complete the review sheet? Well, take a look at this. We have less of the students here that passed the exam than did not pass the exam, whereas when we look above, of those who completed the review sheet, we have more who passed the exam than did not pass the exam. So were the students who did not complete the review sheet more likely? No, they were not. Okay, hopefully that's enough information for you guys to get this topic done. We'll work on it in class. We'll talk about it. If you have any questions, let me know.